Hi students, today's MCQ and the question goes like this. Which of the following functions from this set to this set cannot have the inverse? That is what is the question. From this set to this set is set which contains the elements ABC to set which contains elements PQR. So these are the four options. Here we have not given the function as f of x is equal to something. Here the options are given in the form of ordered pairs where A is mapped to P, B is mapped to Q. That is what is directly given to us. We have to look at the ordered pairs and understand and check whether this function has inverse or not. Now, the very first condition for a function to have inverse is it has to be bijective. That is, the function has to be both 1, 1 and onto. If the function is 1, 1, in the ordered pair, there should not be repetition of any second element. That is, there should not be repetition of any image element. All the image elements should be unique. Is that so? Check the option A. Yes. P, Q, R. All the image elements are different, unique and not repeated. So it is 1, 1. That means what do we understand is each element of the domain set has unique mapping. That is what is the meaning. So if that is the condition, then the function is 1, 1. Now we have to check whether the function is onto or not. For that you have to look at the codomain set. Codomain set has three elements P, Q, R and all the three elements should have pre-images. No element of the codomain should be left without the mapping. So if you look at the second elements, all the three elements are mapped to one or the other elements of the domain set. That is, they have pre-images in the domain set. So second condition or the condition for a function to be onto is also satisfied. This function given in option A is both 1, 1 and onto. This is a bijective function and for this function inverse exists. Now let us check the second one. It's the same condition that we have to check. Look for the second elements. No second element should be repeated. P should not be repeated. It should appear only in one ordered pair. Q should appear in only one ordered pair and R also should appear only in one ordered pair. It should not be repeated. If it is repeated, then the mapping is not unique. That means maybe two elements of the domain set is mapped to same element of the codomain set. So it should not be repeated. Here it is not repeated. So this function is 1, 1. Now let us check for the onto. What is the condition for a function to be onto? P, Q, R. All the elements of the codomain set should have pre-images. That means, look at this. Here, P, Q, R. All the three have pre-images. So this is a function which is onto also. This is a function which is both 1, 1 and onto. So it is bijective, hence it has inverse for it. Hence, the inverse for this function exists. Now look at the options. A has inverse, B also has inverse and option D says both A and B cannot have the inverse. That is not true. Both A and B have inverse. So our right answer is option C. You don't have to check for this, but we'll understand this why it is option C only. So look at this. The condition for the function to be onto is not satisfied. What is it? Look at this. Both B and C are mapped to a single element R. The mapping is not unique, right? So it is not 1, 1 function. Distinct elements of the domain set should have a mapping with distinct elements of the codomain set, which is violated here. So this is not a 1, 1 function. Now, for the function to be onto, all three elements of codomain set, that is P, Q, R, should have pre-images. Now look at this. P has a pre-image, R has two pre-images, but the element Q is not mapped to any element of the domain set. It has no pre-image. It is left without mapping. So the condition for a function to be onto is violated here. So this function is neither 1, 1 nor onto. So it is not a bijective function. Hence, inverse does not exist for this function. So our answer is option C. Whatever I just explained, I have written the same thing here.